I'm Tessa Monroe, and welcome to the pumped up world of pre-algebra.
In part one of this two-part series, we're going to jump headfirst into the mathematical waters, exploring things like exponents, factoring, absolute value, square roots, inequalities, and oh, so much more.
Now, we know that pre-algebra can be kind of a rough ride at times. The standard deviants have scoured the nation for all the introductory pre-algebra material you need to know, and then hired some pretty awesome pre-algebra professors to help us. You can count on us to simplify the stuff and make it easy to learn, easy to remember, and just a little bit enjoyable. Believe it, it's our job.
Since you're watching this on DVD, you have the power to choose how you want to view the program to maximize your mind-expanding mathematics educational experience. Check this out. You'll always start off from a main menu. Anytime you want to start over, just select Menu on your keypad. That'll bring you back to the main menu. From there, you've got lots of choices. You can view the program straight through, select which lesson you want to view, take a quick review, tune into some helpful info, take the Pumped Up exam, our comprehensive final, or learn more about Cerebellum, the creators of this DVD program. You can also hit Previous and Next at any time in the program to jump between major sections without returning to the main menu. What more could you ask for? Now that we got through all that intro stuff, it's time to get to the math. Sit back, relax, and grab a snack. Here we go.
Part 1. Integer exponents.
Section A. What is an integer exponent?
What do we mean by integer exponent? Well, we're really just talking about certain kinds of numbers and the way those numbers are written. First, let's review what an integer is. Then we'll get to exponents.
Remember from basic math that an integer is any positive or negative whole number and 0. So 8, 94, 6, -4, -23, and 0 are all integers.
An exponent is the small number you might see at the upper right corner of an integer. For example, if we see a 2 with a little 5 in its upper right-hand corner and a 3 with a little 4 in its upper right-hand corner, the 5 and 4 are the exponents. The 2 and 3 are called the base numbers. We read these examples as 2 to the 5th power and 3 to the 4th power.
So what does all this mean? It means that when we have a base number and an exponent, the exponent tells us how many times to multiply the base number.
Using our same examples, 2 to the 5th power and 3 to the 4th power, we write them out to look like this. 2 times 2 times 2 times 2 times 2, and 3 times 3 times 3 times 3. When we multiply our first set out, we get 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. That's 5 2's, which equals 32. Now for the next one. 3 times 3 is 9, times 3 is 27, times 3 is 81. That's 4 3's, which equals 81. So, when we have an exponent, we multiply the base number the number of times indicated by that exponent.
So, there's a base number, which we'll call a, and an exponent, which we'll call n, where n is a positive integer. When we talk about a to the nth power as a unit, it's called the exponential term.
As we get into mathematical operations with higher numbers, such as 5 to the 10th power and 20 to the 15th power, writing this out or even punching it into a calculator can be a pretty tedious task. In short, it's a big pain in the neck.
So within the exponential universe, exponentially speaking, there are some rules that can help reduce your workload. Let's see what we've got.
Section B. Rules of exponents.
We can do a lot of things with exponents, and we've got some rules that'll help us figure out how they work. As we go through the rules, we're going to look at them in letter form first, and then plug in some numbers. Don't worry about having the alphabet mixed in with your math. The letters in these rules are just stand-ins until we stick in some numbers. They're just there to help you learn the rule.
Let's look at the first rule, which shows us how to multiply with exponents. We can use it when our exponents are the same for both base numbers that we're multiplying. To use it, just multiply the bases and keep the same exponent. Here's how the mathematicians write it.
If we're multiplying two numbers, a and b, and the exponent n is the same for both numbers, we simply multiply a times b and keep the same exponent n. So if we're multiplying 3 to the 5th power and 4 to the 5th power, the 3 is our a and 4 is our b, while our n equals 5. That means we just multiply the 3 times 4, which is 12, and use the same exponent 5. So 3 to the 5th power times 4 to the 5th power becomes 12 to the 5th power. Easy, right?
Now, before we go on, just a few words of wisdom, like your grandmother would give you. If we see something raised to the 2nd power, we say that it's squared. And if we see something raised to the 3rd power, we say that it's cubed. This is the way you're most likely to hear it, and it's an impressive way of putting it.
If you apply that schnazzy knowledge to our first exponent rule, it looks and reads like this. We've got 6 squared times 4 squared equals 6 times 4 all squared, which equals 24 squared. Multiplying it out, 24 times 24 equals 576.
Okay, let's continue with the rules. The second rule is just like the first, only this time we're going to divide instead of multiply. Check it out.
We use rule number 2 when we're dividing two numbers that have the same exponent n. It states that a to the nth power divided by b to the nth power equals a divided by b to the nth power. So here, 6 cubed divided by 2 cubed would equal 6 divided by 2, all cubed, or 3 cubed. We simply divide the base numbers and use the common exponent. Then, if we multiplied our answer out, we'd have 3 times 3 times 3, which equals 27.
Rule number 3 is a little different from the others. He kind of went his own way. He's a savvy guy. Rule 3 says if we've got a base number raised to a power and the whole exponential term is raised to another power, then we can multiply the two exponents. Take a look at this.
See how we've got a to the n, which is then raised to the m. Notice how we use parentheses here to raise the number to another power. Let's say we've got these numbers plugged in there. 2 cubed, then all of that squared. If we didn't have the rule, we would do what was inside the parentheses first, giving us something like 2 times 2 times 2 equals 8. Then we have 8 squared, which equals 8 times 8, or 64. But just like the other rules, this one is here to help us shorten the process.
Rule 3 says we can multiply our exponents, n and m. So we take 2 cubed squared and multiply the exponents. Keeping the base number the same, it then becomes 2 to the 3 times 2 power, or 2 to the 6th power. When we multiply it out, we get 2 times 2 times 2 times 2 times 2 times 2, which equals 64.
We're over the hump. Just 2 more rules to go. Let's take a look at number 4. This one says when we're multiplying integers with different exponents and the base numbers are the same, we can just add the exponents and use the common base number. Check it out.
Number 4 is written like this, with a to the nth power times a to the mth power equals a to the n plus m. Here's an example. Notice that with 2 cubed times 2 to the 5th, each has a base of 2. So we keep the base number 2 and add the exponents 3 and 5 together. This gives us 2 to the 8th power. And 2 to the 8th power, when we multiply it out, equals 256.
Okay, the final rule is much like the one we just did, except this time we're dividing and subtracting. Take a look at how it breaks down.
We've got a to the nth power divided by a to the mth power equals a to the n minus m. So, if we have 4 to the 5th power divided by 4 cubed, we keep the base number 4, and this time we subtract the bottom exponent from the top exponent. Subtracting 5 minus 3 gives us 2. So now we've got 4 squared. Multiplied out, 4 squared is 4 times 4, or 16.
Now listen up out there, because we're going to give you 2 more hot tips. You might have noticed in these formulas, multiplication and addition go together, and division and subtraction go together. Associating the two might help you remember how the rules work. That's the first hot tip. The second hot tip is you can always check your work just by multiplying the exponents out the long way.
Believe us, checking is a really good idea. We're going to go through one with you right now so you know just how it's done.
Remember, the first rule is a shortcut that allows us to multiply the base numbers and use the common exponent. Well, this is the simplified version. We use it because it's a time saver, and there's less chance of error if we don't have to write everything out the long way. But if we want to check our work, and who doesn't these days, we can always use the longer way. So let's do one the short way, then check it by using the long way. Take a look.
Say we've got an a value of 2, a b value of 3, and an n value of 2. The shortened version gives us the quantity 2 times 3, all squared, which equals 6 squared, which equals 36. Now we can check to see if we did it right by working it out the long way. When we do, we get 2 squared times 3 squared. 2 squared equals 4, and 3 squared equals 9. Next, we multiply these together and get 4 times 9 equals 36. Notice that our check works out, so we know we did it right.
Now at this point, you may be asking yourself some questions.
Why am I here? What is knowledge? Is there such thing as a negative exponent?
Actually, there is such a thing as a negative exponent. When some people see a negative exponent, they run the other way.
Now, there's no reason to run. They're really not that difficult. All we got to do with negative exponents is take the reciprocal of the base number and make the exponent positive.
The reciprocal?
The reciprocal. The reciprocal of a number is just 1 divided by that number. For example, the reciprocal of the number 6 is 1 over 6, and the reciprocal of 3 is 1 over 3. So let's take a look at how we use the reciprocal to make negative exponents positive.
If we're talking letters, we're going to see it written like this. A to the negative nth power equals 1 over a to the positive nth power. That means if we have something like 2 to the negative 3 power and we want to make our exponent positive, we simply place a 1 over the base number 2 and make the exponent negative 3 positive. This gives us 1 divided by 2 cubed.
If we have 4 to the negative 6 power, we convert it to 1 over 4 to the positive 6 power.
Likewise, 5 to the negative 2 power becomes 1 over 5 squared. All we have to do to get rid of the negative exponent is take the reciprocal of the base number and make the exponent positive.
Now, the cool thing about having negative exponents is we can still use all the rules we just learned because they still hold true. We can choose to use the short version or the longer version. We'll show you both.
Let's do the short one first. If we look at Rule 1 and plug in the numbers 2 to the negative 3rd power times 5 to the negative 3rd power, first we multiply our base numbers to get an answer of 10. Then we use the common exponent, negative 3, and we've got 10 to the negative 3rd power. Notice how we still have our negative exponent. We know that 10 to the negative 3rd power can be made positive by placing 1 over 10 and making the 3 positive. So, now we've got 1 over 10 cubed, which equals 1 over 1,000.
Now we're going to do that same problem, but this time we'll use the longer version and we'll make our exponents positive before we multiply. We're doing it this way so you can see there's more than one way to do them and so you can figure out which works best for you.
This time we've got the longer formula, but we plug in the same numbers from before. So we've got 2 to the negative 3rd power times 5 to the negative 3rd power. This time we're going to make the exponents positive before we work it out. So for the first term, 2 to the negative 3rd, we take the reciprocal of the base number 2 and make the exponent positive to get 1 over 2 cubed. 5 to the negative 3rd power becomes 1 over 5 cubed. Now we can multiply these out and get 1 over 8 times 1 over 125. When we multiply these together, we get 1 over 1,000. Notice this is the same answer we got when we did it the other way.
All right, see how we can get to the same place by going 2 different ways? It's good to figure out which way you're most comfortable with, because then you won't sweat so much when you take your tests.
We're through the bulk of the exponent rules, but there are a few more that'll help keep your life simple.
Anytime you see a non-zero number raised to the 0 power, this equals 1.
So, 3 to the 0 power, 6 to the 0 power, 1,300,000 and 2 to the 0 power, they're all equal to 1. Any non-zero number raised to the 0 power equals 1. You may also see it written like this, n to the 0 equals 1. Here's one more easy rule.
Any non-zero number raised to the first power equals itself.
So, in other words, 2 to the first power equals 2, 3 to the first power equals 3, 4 to the first power equals 4, taco salad to the first power equals taco salad. However, taco salad to the 0 power equals 1.
All right, we've got a quick recap of the rules for integer exponents. So sit back, relax, grab your pencil, and open your noggin.
The first exponent rule allows us to multiply two numbers together and use the common exponent when that exponent is the same for both base numbers.
The second rule is similar to the first, except we use it when we're dividing. We can divide two numbers and use the common exponent when the base numbers share the same exponent. Rule 3 says if we have a base number raised to a power inside of parentheses and then raised to another power outside those parentheses, we keep the same base number and multiply the two exponents.
Rule 4 says if we're multiplying two numbers with common bases, then we use the common base number and add the exponents. Rule 5 says if we're dividing two numbers with common bases, then we use the common base number and subtract the bottom exponent from the top exponent. Now, if we have a negative exponent, we make it positive by taking the reciprocal of our base number.
And the last two rules state that any non-zero number raised to the 0 power equals 1, and any number raised to the first power equals itself.
Now, before we move on, one last thing.
Some teachers will allow you to keep your answer with the exponents in, but other ones will want you to multiply them out. Teachers will also have different rules about when and if you can use calculators. Some teachers will even teach you the conga line in class. So always make sure you pay attention to your teacher.